Let's talk about a silent battle happening inside your phone every single day. It's a battle that decides whether an app feels amazing and fluid or, well, frustratingly frozen.
You know the feeling. We've all been there. You launch an app, everything looks good, and then nothing. It just sits there, completely frozen, ignoring every tap and swipe. That feeling of helplessness, it's a sign that behind the scenes a critical fight for resources has been lost. So let's go investigate.
Okay, here's the first number in our investigation. 5 seconds. In the world of mobile apps, that is an eternity. If your user interface locks up for 5 seconds or more, the operating system steps in and delivers the kiss of death, that dreaded application not responding dialog. And just like that, it's game over.
And here is our second critical number. This one isn't the limit for death, it's the budget for life. For an app to feel silky smooth, running at a perfect 60 frames per second, everything, and I mean everything, needed to draw a single frame has to happen in under 16 milliseconds. That's 16 thousandths of a second. Blink and you've missed it several times.
All right, to solve this crime, we've got to understand the victim. So let's meet the protagonist of our story, the single, solitary worker responsible for literally everything you see and touch on your screen.
Think of the main thread, or the UI thread, as a single waiter trying to serve every single table in a huge, packed restaurant, all by themselves. It is a lonely and absurdly important job.
And just look at this list. This poor waiter is doing it all. Drawing the buttons, handling your tabs, running the animations, everything you see, everything you do, it all has to go through this one single thread.
And that brings us to the most important rule in all of mobile development, the one commandment you can never, ever break if you want a decent app. Never, ever block the main thread. Any little thing that makes our waiter pause, even for a moment, freezes the entire restaurant.
So what could possibly cause our overworked waiter to just freeze up like that? Well, when you start investigating, the clues almost always point to the same place. And this is where our mystery really begins.
The solution seems pretty obvious, right? You've got all these slow, heavy tasks, so you just offload them to some background threads. Think of them as the kitchen staff. Let them do the heavy lifting so our main thread waiter can stay out front, keeping the user happy.
But you know, having a kitchen staff creates a whole new problem. What if two cooks try to update the same order slip at the exact same time? You get total chaos. That's what we call a race condition, and it can corrupt your data. To stop this, we use a tool called a critical section. It's like a traffic cop for your data, making sure only one thread gets access at a time. It's supposed to create order.
And here is the plot twist. This very tool, the one designed to prevent problems, is almost always the prime suspect when an app freezes. So, what's the deal? Is the tool itself the culprit, or is something else going on here?
As it turns out, the critical section isn't the killer. It's just the weapon that gets left at the scene of the crime. The real villain, the mastermind that actually causes the freeze, is something way more sinister, a deadlock.
You see, the real enemy here is something called contention. It's basically a traffic jam. It's when multiple threads are all fighting for the same locked resource. The problem isn't the traffic light itself. The problem is the massive line of cars all waiting for it to turn green. That's the bottleneck that brings everything to a grinding halt.
And this slide right here perfectly illustrates the choice developers have, and it's a huge one. On one side, you have a blocking call, something like synchronize. This is like the cook finishing a dish, then walking out into the dining room and stopping the entire restaurant until the waiter is free to take it. This is how you get a deadly deadlock. The waiter is waiting for the kitchen, but now the cook is out in the dining room waiting for the waiter. They're stuck, waiting for each other forever. It's a ghost in the machine that freezes your app solid.
So, obviously, we need a better way. We need a system where the kitchen staff can communicate with the waiter without ever stopping them.
And this workflow, this is the heroic solution. First, our waiter, the main thread, delegates a heavy task. Second, the kitchen, a background thread, does all the hard work. Third, and this is the absolute key, the kitchen uses a non-blocking method, like tthread.queue, to let the waiter know the result is ready. It's basically like leaving the finished dish on the counter and just yelling, "Order up!" Finally, the waiter picks it up and updates the screen whenever they have a free moment. Nobody ever has to stop working.
This is the kind of architecture that avoids those traffic jams completely.
When you design the communication this way, from the ground up, no one ever has to stop and wait for anyone else. The whole system just keeps flowing.
What this whole investigation really uncovers is a deeper truth. It's not about just fixing a bug. It's about a fundamental shift in mindset, about where the real problem lies.
The worst mistake any of us can make is just guessing where the problem is. This famous quote from the legendary Donald Knuth says it all. Optimization has to be a science, not just a hunch. You have to measure first, use the right tools to find the real bottlenecks, and only then should you act.
And this, right here, is the ultimate takeaway. We have to stop blaming the tool. The goal isn't to just avoid critical sections. The goal is to design systems where the very condition that makes the tool dangerous, that contention, that traffic jam, can't even exist in the first place.
So the goal is to become a better architect. It's about building a system so well designed, so efficient, that those resource traffic jams just never even have a chance to form.
Which brings us right back to that tiny number from the beginning. With every single frame, you get a budget of 16 milliseconds. So now, with these tools and this new way of thinking, the only question left is, how are you going to spend yours to create the best possible experience?